All right, weekly contest 469. It's already done. So the first question, compute decimal representation. You are given an positive integer n. A positive integer is a base 10 component if it is a product of a single digit from 1 to n and a non-negative power of 10. For example, 530 and 7 are base 10 components, while 5 through 7, well, 2 or not. Express n as a sum of only base 10 components using the fewest base 10 components possible. Return an array containing these base 10 components in descending order. So yeah, what I'm thinking is maybe we can do this greedily. So we're given 537 is a product. Okay. So what's this one? It's a digit and a non-negative power of 10. Okay. So I think this one is like 5. This is a base 10 because it's 5 power 2, right? Or no, what is this? What the heck is this? What's a base 10 component, bro? Is a product? Oh, negative. Oh, so okay, so it's like 5 times 10 to the power of. Okay, it's a product of a single digit. So the first one is 5 times 10 to the power of 2. What's 10 to the power of 2? 100, something like that? Or is it just like, or is it like 1 times 10 to the power of. No, no, no. It's 5 times 10 to the power of 2. Yeah, yeah. So I think it's anything like. Oh, this is pretty easy. I think every anything like that's a anything that's a multiple of 10, right? So I think if we have a 537, like we can just look at any of these. Like what is the biggest multiple of 10? Like how do we figure out to subtract 500 off of this? Just straight cast a string? Let me think about it. Like how would we know to subtract 500 off of this? Yeah, maybe we just do maybe we like mod this by. Let's see. Well, we know that it's 3 digits, so we know it's like 10 to the power of 3 or something. Or yeah, we know that it's like 10 to the, cuz I think how this one is 10 to the power of 0, this is 10 to the power of 1, this is 10 to the power of 2. So we know the very left is 10 to the power of something. Or sorry, that we know the very left is 10 to the power of 2. So I think all we need to do is based on here, we just do 10 to the power of 2. I think we just move from left to right. I think we just multiplied this number by its index. So we say 10 to the power of something by that digit. Like simple math. So for example, this is 10 to the power of 0 times 7. This is 10 to the power of 1 times 3. Yeah, I think that's as simple as that. So just go like this. And then we say, holy, I haven't done LeetCode in a while. Length of -1, 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. So we start with power like this. Oh no, but it's going to be in reverse. So I think so we have 537. So if we start with a power of 0, yeah, all we need to do is we have result. We might need to reverse this eventually, but what we say is like result dot append int of and string at I. So we convert that times 10 to the power of the power. Plus equals 1. Turn list reversed result. The hell? Oh yeah, yeah, if it's 0, that we don't have to include that. Bad variable names, but like we need to increase the power anyways, but we'll do. Yeah, I forgot about including zeros. All right, that's a good one. Follow up. Do it without converting to string. How do we do that? Dude, I'm gonna ask people this. I feel like some people would fold on that. I mean, I would just right shift it, right? Or like, yeah, mod 10 to grab this 7. Yeah, mod 10 then divide it by 10. That would get 7. Yeah. I can implement it like that too. All right. Next question. Wait, let me grab some water. Chat, this is the next question if you want to try it out with me. Grab some water. 2 seconds. It's like I haven't looked at my phone in hours. Let me reply. Yo, y'all like who here likes Dave's hot chicken? Okay, you're given an array of nums. Split the array into exactly two subarrays. Left, right, such that left is strictly increasing and right is strictly decreasing. Return the minimum possible absolute difference between the sums of left and right. What? If no valid split exists, return -1. Okay. Let me reread this again. Yeah, Dave's Hot slaps. They don't have a Dave's Hot in SF though. So split the array into exactly two subarrays, left and right, such that left is strictly increasing and right is strictly decreasing. Okay, I see. So we we need to just build two subarrays. One is left, one is right. And then we need to minimize the absolute difference between the two. Okay. I see. So for this one, we take the 1 here, and then we take the 1, 3 in the other. So the sums of left and right. So left and right. So there's two ways that we can split it. We can put 1, 3, and 2, or 1, 3, and 2. Left sum equals 1. Right sum equals 5. The absolute difference is 4. Otherwise, yeah, this is the smallest way that we can do it. Okay. So 1, 2, 4, 3. What are the different ways we can split it? Why are they using I there? What does I represent? Oh, you can't reorder. Oh, I see. You're not reordering. That makes it, I think that's easier. Yeah. So we have 3, 1, 2. Like, we can't even split this one because if I have 3, if we split it here, this one is ascending. That doesn't work. Yeah, I think we could just brute force check all of them and the absolute difference. Yeah, exactly. It has to form a mountain. Dude, that's a good way to look at it, Alpha. Yeah, see, like, for example, if I had a mountain, right? If I split here, this one's gonna have a less value. And this one's gonna have a greater value because it includes all these ones. So the difference is gonna be, yeah. So I think we can maybe run two checks. First, see that it's see that it forms a mountain. That it I think that works. We need to see that it forms like some sort of mountain where it's increasing then decreasing. And then all we need to do is just find the top. Because if it's ever like increasing, decreasing like this, that'll never work. Because wherever you put it, like if I put it here, this side is not decreasing. If I put it here, this side is not just increasing. So I think all we need to do, I think it's probably as simple as like figuring it out. Wait, strictly increasing? Okay, I think it's as simple as like, yeah, finding where the peak is. And then when I find the peak, I just need to make sure that it decreases from there. So I think it's just as simple as that, like a greedy solution. And if I ever find it, like go up and down, and like I think it makes it easier that it's strictly increasing. If I ever see that like the like if I ever see like the last value stays the same, it's an error. And if I ever see that like it goes down more than once, Or like if there's ever like if it ever zigzags or like changes direction more than once, it's an error. So I think we just need to capture the direction, and then like we just need to find the peak. I think no, I don't think it could ever be empty. Wait, why is this so low? Why is the acceptance rate so? I don't think it could be ever empty. You have to split it, like left and right have to be non-empty. It has to be non-empty. It can't be empty subarray. So that makes everything simpler. Yeah, I think we just need to find peak indexes. Yeah, we just need to find peak indexes, but like there can't be multiple peaks. But what if it's just like this and there's just one peak index? Bro, there's so much ways that you can solve this. I'm just trying to like really think about the most simple way that we should implement. Yeah, like this one, if it's just strictly increasing, like we need to find a peak, and it needs to be exactly one peak. Okay, and then we just need to return. Okay. If the length of peaks is not equal to 1, return. So all we need to do is like loop through numbers for I in range. Oh, but we need to calculate the absolute difference. So we need to like actually get the absolute difference of each side. So I think we just create left equals 0, right equals the sum of nums, right? So for I in range length of nums, what we're going to do is we're going to do left plus equals nums at I. And we're going to say the right minus equals nums at I. So that'll like, yeah, this will become 1 and then, yeah. So now we get that. Now we need to see if it's a peak. It can be a peak here. Wait, 1, 2, 4, 3. Why is this not valid? Oh, you're right. Dude, there's edge cases like crazy. Yeah. Yeah, because it could just be like this. That would work. That we just partition like this, partition like that. Or if this is 5, yeah, and then this decreases. Like if I chose 5 here. Yeah, but which 5 would I choose? Look at 10. Or no, that doesn't even matter. You would just have to split it on the 5 there. I mean, that's just like an edge case that we need to capture. Yeah, 1551 is valid. Yeah, that makes sense. Okay, how would I handle that? I think we could just keep a prefix sum if it's decreasing or not. So we just say, so we could just cache the results, honestly. So we could just like store, like we can have like, if this is decreasing, we could say decreasing, 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 like a prefix sum. And then like the moment starts increasing, like we could just put that false. And then we could just store it from this side, increasing, increasing. So at every index, we could just calculate like if I'm here, if I portion here, will it be increasing all the way? Yes. Will it be decreasing to my right? No. Yeah. I think we could just do it with extra space and just calculate like we can have increasing and decreasing like arrays. So increasing. Oh, could we just like, is this valid syntax? Go. Yeah. So we do increasing. So for increasing, there's gonna be a lot of code. We can probably simplify this, but we'll go. Find range. If I is equal to 0, using I is equal to if nums at I is greater than nums of I minus 1. So it needs to be greater than before, and the increasing I minus 1 is true. So let's like print increasing. So you can see for this one, it's true, true, then false. That makes sense. Now we just kind of have to do the reverse for decreasing. Yeah, you're right, you're right, you're right, you're right. Rookie move, rookie move. Thank you. Greater than last. Yeah, like calculate those prefix sums like that. What? Why is this false? This first one should be. So for decreasing, the first one should, if the I is equal to length of numbers minus 1, decreasing I equals to true. Oh, sorry. So dim. What? Decreasing. So the first one should be true. If I is equal to... There's probably a small bug I have here. Oh, I wasn't reversing from the back. Okay, true, true. Okay, false. So now all I need to do just use those upper extra space for I in range length of nums. Oh shoot, I have to do that like left equals 0. Right equals the sum of nums. Right? So what I'll do is left plus equals nums at I. Right equals length of minus equal nums I minus 1. Or sorry, nums at I as well. If increasing at I we don't want to go all the way up until the end here too, because we need to check. Yeah, I think we could just like go here, but if it's increasing at I and decreasing at I plus 1, then we're gonna do result equals absolute difference of right minus left. Let's go. What? So do we just min? Or what? Yeah, we want to minimize. Yeah, min. Result. Wait, what? Use test case. Oh shoot. Making some rookie results. If we're minimizing, we're gonna put this float infinity. -1 if result. Use test case. Use test case. Solved. I don't know if I want to do the... Yo, this question is way easier than the last one. Or this... Oh my god. Yeah, I'm not doing this question, man. Alright, chat. That was already 3 hours. Had a lot of good conversations. Did a coding interview. Guy did pretty good. But I'm not working on this hard question. Catch y'all in the next stream. Appreciate y'all. Gonna head out. Thanks for tuning in. I'll let y'all know when I'm streaming next. Probably next Saturday from early in the morning next Saturday. We'll see. Let's see how work goes. It's gonna be like on the spot real quick. But have a good night.